Hey there, science fans! Today we're diving into the fascinating world of information technology infrastructure. Think of it like the nervous system of an organization, carrying vital information to every corner. IT specialist. At the heart of it all are networks, connecting devices and enabling communication. These networks rely on servers, powerful computers that store and manage data, kind of like the brains of the operation. Now imagine you're building a giant Lego castle. You need a plan, right? That's where network architecture comes in. It's the blueprint that determines how everything connects and communicates. It's specialist. We also have storage, the treasure chests of our digital world, holding everything from precious photos to important documents. And of course, no IT infrastructure is complete without endpoint devices, like our trusty computers, smartphones, and tablets. These are the tools we use to access and interact with the digital world. But where does all this stuff live? Well, it can be on premises, meaning physically located within the organization's own buildings. Or it can be in the cloud, which is basically a bunch of powerful servers located in data centers around the world, all connected through the internet. Think of it like renting space for your digital stuff instead of storing it all in your own house. IT specialist. Both on-premises and cloud computing have their pros and cons. On-premises gives you more control over your data, but it can be expensive to set up and maintain. Cloud computing is more flexible and scalable, but you're relying on a third party to keep your data safe and secure. The choice depends on the specific needs of the organization. Just like choosing the right Lego bricks for your castle, it's all about finding the best fit. All right, science enthusiasts, now that we know the players, let's talk about how they communicate. Just like we use roads and highways to get around, data travels through transmission media. Think of these as the information superhighways of the digital world. There are two main types, wired and wireless. Wired media, like copper cables and fiber optic cables, use physical wires to transmit data. Copper cables are like the trusty old roads of the data world, while fiber optic cables are like super fast bullet trains, transmitting data as pulses of light. Wireless media, on the other hand, uses electromagnetic waves to transmit data, like radio waves and microwaves. It's like beaming information through the air. Each type of transmission media has its own strengths and weaknesses. Wired media is generally faster and more reliable, but it can be expensive to install and inflexible. Wireless media is more convenient and flexible, but it can be affected by interference and has a shorter range. Choosing the right transmission media is like choosing the right transportation method for your journey. A short trip across town might call for a quick bike ride, while a cross-country adventure might require a plane ticket. It all depends on the distance, speed, and reliability you need. Hold on tight, science buffs, because we're about to encounter some roadblocks on our data highway. Just like real roads can be affected by traffic, weather, and construction, data transmission can be slowed down or even blocked by various factors. IT specialist. First up, we have distance. The farther data has to travel, the longer it takes. Think of it like driving a car. A cross-country road trip takes longer than a quick trip to the grocery store. Next, we have topography. Mountains, valleys, and other geographical features can interfere with wireless signals, just like they can make it harder to build roads. IT specialist. Then there are physical barriers like walls, buildings, and trees. These can block or weaken signals, making it harder for data to get through. Imagine trying to drive through a thick forest. It's not easy. And finally, we have environmental barriers like rain, snow, and electromagnetic interference. These can all disrupt wireless signals, kind of like how a rainstorm can make it hard to see the road ahead. IT specialist. Just like we need to be aware of road conditions when we drive, it's important to consider these factors when designing and managing networks. By understanding the challenges, we can find ways to overcome them and keep the data flowing smoothly. Buckle up, science fans, because we're going to learn how to optimize data flow and keep the information superhighway running at peak performance. Just like traffic engineers use strategies to reduce congestion and improve traffic flow, network administrators use various techniques to enhance data transmission.
One important factor is antenna size and location. Think of antennas as the on and off ramps of our data highway. Larger antennas can send and receive signals over greater distances, while strategically placed antennas can help bypass obstacles and improve coverage. It's like building bridges and tunnels to keep traffic moving smoothly.
Another important aspect is traffic filtering. Just like traffic lights and roundabouts help regulate the flow of vehicles, firewalls and routers can control which data packets are allowed on the network and which are blocked. This helps prevent congestion and ensures that only authorized traffic gets through.
Flow scheduling and monitoring are also crucial for optimizing data flow. By prioritizing certain types of traffic, like video conferencing or online gaming, network administrators can ensure a smooth experience for users. It's like creating dedicated lanes for different types of vehicles on the highway. And by constantly monitoring network traffic, they can identify and address potential bottlenecks before they become major problems.
Get ready to be amazed, science aficionados, because we're about to enter the world of the Internet of Things. This is where everyday objects, from refrigerators to thermostats, become interconnected, sharing data and making our lives easier and more efficient. Imagine a world where your coffee maker starts brewing as soon as your alarm clock goes off, or your lights automatically adjust based on the amount of sunlight outside.
But how does it all work? Well, each device in the IoT ecosystem has sensors, actuators, and communication capabilities that allow it to collect and exchange data with other devices and systems. This data can then be analyzed to gain insights, automate tasks, and improve decision-making. It's like giving every object a voice and a brain.
One example of IoT in action is SCADA, or Supervisory Control and Data Acquisition Systems. These systems are used to monitor and control industrial processes in real time, such as power generation, oil and gas pipelines, and water treatment plants. By collecting data from sensors throughout the system, SCADA systems can detect anomalies, optimize performance, and prevent costly downtime. It's like having a team of experts constantly monitoring and adjusting the system to ensure everything runs smoothly.
Of course, communication protocols are essential for enabling seamless communication between all these devices. These protocols are like the languages that devices use to talk to each other, ensuring that they can understand each other and exchange information accurately. Some popular IoT protocols include MQTT, CoAP, and Zigbee.